Hello, welcome to the New Stack Makers, a podcast where we talk about at-scale application development, deployment, and management. Thanks for joining us today. This is Swapnil Bhartiya for the New Stack. Let's go and meet our next guest.
So here we are, once again at Open Source Leadership Summit in a beautiful town, Sonoma.
It's beautiful in Sonoma today, yeah.
Yeah, it is. It is beautiful, though at evening it gets cold, but it's a lovely town, and it's also lovely to meet you again after DockerCon.
Yeah, it was really good to talk last time.
Yes. So before we kind of deep dive into this interview, Patrick, can you just tell us about yourself and what do you do at Docker and CNCF?
Sure. Yeah, so I'm Patrick Chanezon. I'm a Chief Developer Advocate at Docker. And I'm also the representative of Docker to the Cloud Native Foundation board. And so we had a board meeting yesterday. That's why I came to that conference today.
And I think they announced that Kubernetes has kind of entered the graduation phase. So a lot of things are going on. I mean, as a journalist, it's fun to be in this part. So these days, a new buzzword that we keep hearing is microservices. What is microservices architecture? Can you talk about that?
Yeah, so it's not a new buzzword anymore. Mm-hmm. It's been so microservices is an architecture style. It's a way to structure software, and it's been around for a few years now. But yeah, it starts to get more buzzy right now because we see more practitioners in the enterprise starting to refactor their existing applications in microservices. So the architecture style itself is opposed to monolithic applications. Mm-hmm. In the end of 90s to early 2000s, developers were structuring their applications into what we call monolith. So it would be your Java Enterprise application, your WAR file or EAR file in the Java world, your ASP.NET application where you would bundle all the functionality of an application or all the APIs surface of an application into a single monolithic artifact that then you would run on some type of app server, either IaaS in the .NET world or a Java app server in the Java world. Mm-hmm. And so you would have everything together, and when you upgrade the application, you would upgrade all these different services together. And what happened in the past 5 years, so Docker is celebrating its 5th birthday in March. Mm-hmm. In the past 5 years, with the rise of containers, people have started to break these monoliths into what are called microservices. And the idea there is that you're building your application as a set of loosely coupled services that can be updated and scaled separately. Mm-hmm. And the container infrastructure or the container platform that's behind them, typically to run them, allows you to update them pretty easily, scale them in a very automated way. And now as a developer, when you're building your application, you can just focus on one specific set of business concern that one microservice is going to take care of. And then you could have another team working on another aspect of the application, and the two can be updated faster. So this architecture style came into prominence thanks to, I would say, three different trends. One of them is the rise of agile methodologies, where developers are building systems that are always running. They build up from a small base and they try to avoid taking too much risk on the design side, involving users to get users' feedback and iterating very quickly on them. So that's agile. Then a prolongation of agile to the ops world is a trend or a cultural movement called DevOps, where devs and ops are working together on a single application or a single microservice that they build and operate together. And then the last one is containers, which is the technology that enabled all that to work really well.
And how does microservice fit into the whole cloud native
Yeah, so so it's really interesting that you're asking the question, because in the board meeting of the Cloud Native Foundation yesterday.
Yeah, questions are coming from some context.
Yeah, so we just had a discussion about that. The Cloud Native Foundation, when it was created, I think we created that like 2 years ago.
Mm-hmm.
When we created it, or 3 years ago, we had in the charter of the CNCF, we had a specific definition that was a good fit at the time. And right now in the CNCF Technical Oversight Board mailing list, there's been a discussion about renewing that definition to be a little bit more inclusive of all the stuff that has been invented since in these 3 years. And so microservices are part of it, container-based are part of that, but you have new things like a service mesh or function as a service. So it's a space that's evolving very quickly with lots of new technologies and lots of new projects. And you saw that with the number of projects that CNCF now has. I don't remember how many we have, maybe
a lot,
12 or something like that. Another thing that that was voted, I think today, it was announced today in the mailing list, in the TOC mailing list, is a new category for projects called sandbox projects. That wouldn't be CNCF projects per se, but it's the area where you can start contributing code with the goal of becoming a real CNCF project. Because there are so many innovations in that space that there are lots of projects that may not meet the bar of being a CNCF project right away, but they can start in the sandbox.
You mentioned that CNCF is trying to define what it means to be. You also mentioned service mesh.
Yes.
So when you are look at microservices, what are the challenges? And because a lot of like if you look at networking, a lot of things they were there before microservices came.
Yes.
So microservices have some expectation with these existing stack. At the same time, the existing stack expects something from. So new patterns are emerging. Service meshes. So can you talk about what are the challenges for microservices and how service mesh?
And actually, service mesh is a set of technologies and projects that try to tackle one of the challenges with microservices, which is observability. When you start to break your monolithic application where you had everything in the same code base all together, and it was pretty easy to see what was happening in there. When you start to break them into different processes that eventually run on different machines and that talk together through the network, then for one user request that's coming in the user interface, maybe it will go through 15 different services and backend services before going back to the user. And understanding as a developer or an ops what's happening at that time. Where do the requests go through? When there's an error, how is it handled? What are the performance characteristics of your system? You need an observability layer. And service meshes help you with observability. Typically, what they consist of is a way of doing the routing of the request in a pretty transparent way so that not each application developer has to reinvent that. It's added transparently in the system. So as a developer, you just package your microservice as a container. You deploy it on a platform such as the Docker platform or the Kubernetes orchestrator. Actually, Docker platform now includes Kubernetes. And then you add a service mesh on top of that that adds some transparent proxies between the different microservices so that when they call each other, these proxies can get some data about some performance data and log these performance data. They can add some transaction IDs in order to trace the transaction later on. And then, based on all that data, they can give you either the developer or an ops. They can give you a full trace of where the request came through, where your bottlenecks are, or what kind of issues do you have in production.
Right. We also talk about, when you talk about scalability, So, does it kind of, it still allows for scalability or?
Oh, definitely. So both container platforms and service meshes help with scalability. The whole notion of breaking down your monolith into different microservices is that when your system is under load, not all the parts of the system will have the same scalability requirements. So once you have broken up your monolith into different microservices, let's say the backend service that's talking to the database, maybe this one will need to have 10 instances or 3 instances, and then your front end, which will handle a lot of requests from customers but call many different backend services, maybe this one will need 100 of them. So you can scale them independently. And also the fact that the orchestration layer gives you, when you're applying monitoring, gives you some pretty rich data. You could even build things like autoscalers that let you scale your service in an automated way.
And when these companies, they break their monoliths and break them into microservices, what kind of challenges do they themselves face? And because in open source where you reuse everything, so do they kind of create kind of some technical debt also in the process, or?
I'd say usually breaking down your monolith into microservice typically is more it's something that you're doing to pay technical debt back. So if you're looking at Docker Engine, actually Docker Engine itself is a very good example of that. So Docker Engine is an open source project. It's the Moby project. And over the past 3 years, our team took a lot of effort to take that monolithic code base of the engine and break it down into these different components. So you have containerd that is called container runtime, build kit that's doing the build part, and so we're trying to break down Docker itself, the Docker engine, into these different microservices. So that's what typically, and that's to pay technical debt, because then we have these loosely coupled components that can be reused in different contexts. So for example, containerd is used in Docker Engine, but it can be used directly in Kubernetes as well. And so developers in the enterprise who are building these applications, typically when they take a monolithic application and break it down, they are paying technical debt. Now, one of the patterns that we've seen emerge with our enterprise customers is that very often they don't completely do that. What they do is that they do what we call modernization of traditional applications. They take their traditional applications that are sitting on a VM or on bare metal. They start by containerizing it, and once they have that monolith in a container, they not necessarily invest into breaking it down, but they add microservices around it on the same network, because now that they're containerized, it's very easy to add other services to it. And then they add more business value out of these assets and the data that are associated to it in order to make them do some new things. And so the example that you saw at DockerCon last time that IBM showed was to take the old Java pet store and make it a mobile application that recognizes pictures of dogs and can send you a pet proposal from the pet store without changing any code.
That's excellent. You did mention that getting rid of you're kind of paying technical debt, and then you also mentioned Docker itself is open. So this is like general question that I'm using for other documentary kind of project. So how important is, because we are also at Open Source Leadership Summit. So as all of these new modern economy is being powered by open. So what is the role open source is playing today?
So in the keynote this morning, Jim Zemlin explained it really well. Open source is about collaborating as a community around projects, and then commercial companies who may be competing may be working together on the same projects, and that's what's happening with the Moby project or with Kubernetes. So we all collaborate together, while after that we take these components and we build solutions that then create value for customers. And then at this level of the solutions, we're competing. So for example, Docker is building the Docker platform out of Moby. many of the Moby projects as well as Kubernetes. We just assemble all that into what we call the Docker platform, and we sell that to enterprises. And there we're competing with Red Hat and maybe Pivotal as well. But when you're looking at the projects themselves, on the open source projects, we're all collaborating.
Right. Yeah. So the sales team kind of compete, developers collaborate.
Yeah.
That's how it works mostly.
Yeah, exactly. And we're creating differentiation at the solution level.
Yes. And one more question of the previous part was that, can you talk about any deployment from Docker's perspective of microservices?
So we have lots of our customers who are deploying microservices. Very often the adoption of Docker took the following patterns. In the past few years, I would say, you had advanced departments, development departments of companies who are doing Agile already, who started to get into DevOps. They adopted Docker to do CI/CD, DevOps, and then they started to build microservices applications for greenfield type of applications. I'd say that was the first 3 years of Docker. In the past 2 years, what we've seen is lots of enterprise customers are doing that modernization of traditional applications, and we see a lot of that. So today, I'd say the biggest use case we see is modernization. We see a little bit of microservices. Very often they go together. And then the research departments or the people who are looking at technology trends, they start to get their feet wet with function as a service or serverless, typically running on top of a container platform.
Okay. Before we wrap this up, so what brought you to Open Source Leadership Summit, and what are you doing here?
Yeah, I mean, I came, so we had the board meeting yesterday for CNCF, so I came for that and to meet all my colleagues who are part of the CNCF community. And then there's also a lot of friends of different projects that I'm meeting there between the different talks. I've been in the industry for a long time, so my friends are in most of these other companies. And what Jim said this morning in the keynote is that we're all collaborating together to raise the level of abstraction of the stacks that we're creating in order to create value for our business customers.
And he also mentioned that it's less about let's collaborate. It's also about getting into details. It's easy to say to collaborate, but actually getting into detail to how it's done, what is to be done, and how to solve problems. That happens only when you bring everyone together under the same tent.
There's lots of detailed work that needs to happen, and you can actually see that happening in real time on the different mailing lists.
Right. Everything is transparent.
Everything is open. Chen Goldberg, I liked her talk really well this morning. She's from Google, and she explained that when they decided to open source Kubernetes, it was really a business decision. It was tied to their strategy, and they made it in the open from day zero, where you could see the first community meetings that are recorded. So all the decisions are pretty transparent, and you can see that in the CNCF TOC mailing list. The definition that I was telling you about, they're having debates about that right now. Which project is getting in, it's also completely transparent. They have meetings on Tuesday mornings every 2 weeks, and so there's one. There's one. Which day are we?
I'm not part of. I don't sit on the board, so I cannot, tell you that. But it was very impressive that she said, that open source is not an afterthought. It's like part of the strategy. When they're working on Kubernetes, all those technologies at Google. So that was a nice talk. And either way, it was nice. Anything else you would like to touch upon?
Just one last thing is, if you're a developer today. The world is your oyster. There's never been a better time to innovate.
Right.
What I found really fascinating about containers 5 years ago, when Docker appeared on the scene, is that it enabled you, the developer, to build systems out of components in different languages. So you could leverage components in different languages that you not necessarily knew. Tying them together with virtual networking that a container platform offers you. And today we're seeing the results of that with these kind of 3 types of architecture. Monolithic, you can reuse your old code base. Microservices, you can create new microservices that interact together and can complement the old code base. and then functions which are even more lightweight that respond to events and can even help with existing applications. And then you have the new type of workloads like distributed AI, like deep learning models, like distributed TensorFlow that runs on top of Kubernetes.
Yes.
So as a developer, it's never been easy to assemble a system that's pretty complex that would have taken years of R&D 10 years ago.
Right.
That as a single developer or as a small team, you can create a lot of business value and reinvent whole industries. So if you're a developer, get started with containers, microservices, modernize your traditional apps, take a look at serverless and AI workloads.
I remember last time when I was talking to Kelsey Hightower, he said that another beauty is that it's open source. So you are not expected to come with a lot of experience and everything that happened in the proprietary world. As you said, the whole world is oyster. So you can just deep dive into the code in any GitHub repository. Start learning. You don't have to.
You can start on your laptop. It's super easy.
Super easy.
At Docker, we made it even easier recently to play with Kubernetes by adding Kubernetes in Docker Desktop.
Yes.
So it's on your Mac or Windows, and it's just a checkbox. You don't need to.
Right.
It doesn't need to be hard to install, and then you can start playing. Typically, for enterprise users, they'll need a product to do role-based access control and security and all that. But yeah, many of these technologies are open source, and it's super easy to get started and share with the community.
Yeah, that's all it is about. Thank you, Patrick, so much for talking to you again. Yeah, hopefully we'll see you again at the next
definitely at the next event.
Yes.
Listen to more episodes of the New Stack Makers at thenewstack.io/podcast. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time.